Hello.
Hello.
Yeah, Atul Sharma. Good evening.
Good evening. No, I just a little bit query like if we design tube sheet with lip, so we have to consider lip as a step.
Tube sheet with limb.
The lip.
Okay. Uh,
In tube sheet, so then we have to select a step tube sheet. We have to consider the step as a lip, or we have to put same material cylinder.
uh, you want lip in the tube sheet.
I am designing a fixed tube sheet exterior,
Okay.
which tube sheet is extended with lip.
Okay.
Then there is a checkbox. If there is a step tube sheet, we have to enter step, cell side and tube side.
Okay.
Then this lip we have to consider as a step, cell side.
Yeah. Actually, this lip, whatever you are considering, this is step which is going inside this shell, right?
Yes, yes.
This shell is connecting on that one, and then it's they are welding. So this step is in the tube sheet. So the whatever the material you have, the tube sheet material, that tube sheet material you have to consider for that one.
If I am considering lip as a cylinder, then I have to select it as a cell side material.
Shell side material, not a tube side, tube sheet material.
No. Material, but not material. Cell side part, where we have to put for tube sheet analysis. Cell side part.
Yeah, shell side.
Okay.
Okay. Wasif, you're welcome. Your voice is not. Atul, are you able to hear Wasif voice or something?
No, I have no any questions today.
Okay. How do you feel this on used to come? So how do you do this horizontal heat exchanger bracket calculation in that one?
No, as per Dennis-Moss, there is and in Dennis-Moss, they given some data, then we make a Excel sheet, then we submit it to the client.
Okay. Means you are doing in the Excel, means in manual calculation you're doing. It's not in the
In
PVLA.
manual calculation. For bracket, we are providing manual calculation.
Okay. In PVLA there is no option for bracket.
Yes. Typically, there is no option for horizontal bracket support.
But there is a bracket support for vertical is available. So
Vertical is available. Mostly, the vertical foundation is like a brackets foundation platform.
yeah, on platform it's vertical, and in that one also, while in vertical design, it not consider the bottom part. I mean, in wind and that one, it will not consider the bottom part. So whatever
It is not considered.
above the bracket only it considers, and it's give the calculation for in PVLAT.
Yes.
In that one also we have to go for this G loading and that one.
G loading.
Okay. Vertical is available. So
Vertical is available. Mostly, the vertical foundation is like a brackets foundation platform.
yeah, on platform it's vertical, and in that one also, while in vertical design, it not consider the bottom part. I mean, in wind and that one, it will not consider the bottom part. So whatever
It is not considered.
above the bracket only it considers, and it's give the calculation for in PVLAT.
Yes.
In that one also we have to go for this G loading and that one.
G loading.
Okay, but in Dennis-Moss you are using, and you are using Excel and in horizontal.
Yeah, we are using Dennis-Moss only.
But Dennis-Moss it's given horizontal heat exchanger bracket calculation there.
No, there is a leg support option.
What option?
Leg support.
Leg support. Okay.
leg support. So there they mention data how to take the dimensions, actual dimensions.
Okay. So
I will share you my code one Excel.
code 1 Excel.
Yes. Little bit query. There is a heat exchanger in SS.
Heat
It is a vertical exchanger, and there is a channel cover, and channel cover has an opening to multiple openings. An opening channel cover thickness is 100 mm, and channel cover MOC is SS. And we have to do solution annealing.
Vertical heat exchanger.
Vertical heat exchanger. There is a channel cover on top.
Okay.
And channel cover has multiple openings.
Okay.
Channel thickness is 100 mm.
Okay.
So we have to do welding 100 mm.
Okay.
So due to 100 mm welding, fillet weld lag is also higher filler material. So we have to require solution annealing like heat treatment.
Heat treatment for SS is not required because
No, it is not required, but there is mention if fillet weld lag is greater than 1.5 inches.
okay, 1.5 inches. If
37 mm, more than 37 mm, so you have to do 100% RT or solution annealing.
yeah,
Because
100%
in code-
100% RT you have to do, and yeah,
But exception for solution annealing is in code UH52 is if design temperature is more than 530, then you have to do. And below then, heat treatment not required.
so you were more than 530 temperature.
No, I have no. My design temperature is low,
Okay.
but I can't do 100% RT at their joint.
So to
Because,
yeah.
because RT is possible in butt weld, and there is no butt weld, there is a circumferential welding.
Okay. So to check that RT and that one, you want to means RT is not possible. That's why you want to do the heat treatment.
Yes.
But heat treatment and RT are two different things.
Yeah, both are different things.
Yeah.
But we can't choose RT over there. But we are doing grain reforming.
Yeah, grain reforming, but this RT and that one, it's to check the defects on that one. But heat treatment, when there is a stresses in the material and that one, on that time to release that stresses in the material, you are doing this heat treatment. Heat treatment means you are heating that material and releasing the stresses which contains in that material. So it will releases that because when you weld, there is a high temperature you put on that material and you deposit on that one. So to release that whatever stresses it inbuilt that one, to release that one, it will we need to do heat treatment. And normally heat treatment for SS, and there is no why this is the not to be done on SS material due to that the stresses formation in that one, it's a minimum, it's not that much compared to the CS material or any other material in that one. So that's why this is that in SS not required. And this RT, if when you weld that one and there is some porosity or some foreign metal, something, if something inside or some holes created inside when you welding, to check that one you are doing this RT and that one. So any defects or anything to avoid that one.
No, RT is doing is not a major deal. Major deal is how to do RT in a circumferential joint, because in our shop, quality team is, I think, is not capable to do circumferential RT. They are all experienced in butt weld RT. I am thinking part of them. I can put a mention in drawing 100% RT is the channel cover, but they will able to do it is a question, because I consult with my quality team. They are saying we can't do.
Yeah, there might be they're not able to put the film and that one on that welding and whatever the weld you are saying. Maybe because to cover that complete weld, that film, the RT film should be completely covered. Then only they can able to. If film not able to put on that one, so they are not able to do that RT and that one. That's why they might be saying. Yeah.
Then I am thinking I will take an exemption and not heat treatment required, not RT required. Let's see what happens in the future.
No, but heat treatment and this RT both are different things. You can say any other inspection thing like that. You can do some maybe some magnetic this one MT
So
and that one.
magnetic is same as a UT.
Yeah,
UT will replace magnetic.
yeah, yeah.
We can't do anything. So that's why I'm ignoring all the. Let's see what happens in future, and third party will say.
Mm-hmm. Okay, then check that one. Whatever possible, you can apply that one or consult some higher inspection agencies and that one. They will guide you. If it is not
Yeah,
possible, then
sure.
what can be done? So they will inform. Okay. What is your query?
My query is I have to perform FEA calculation for tube bundle. How can I do that in Excel?
Tube bundle, you want to do FE calculations.
FEA calculation for full tube bundle.
Okay. So ANSYS means you have the ANSYS software with you?
No, I did not have. I just want to know how they will do.
They will like nozzles and that one. Normally how they'll do, they enter the each part in that one. Like if tubes are there, then they enter the tubes and that one. Then what are the material it's using, that material they will enter that one. And they will apply the other things also, like thermal means how much temperature and that one, how much temperature is considering and how much loads are coming on that one. So these all what your parameters are there, they enter that one, and they mesh. They'll do the meshing of that one. Means there are fine meshing is there, some normal meshing are there. So accordingly they will select. If your results are very fine tune, you require then fine meshing they will do. And accordingly they will, whatever the loads and that one, your tubes are connected to Tubesheet, and that also they will model in that one. And whatever the loads are coming, they will apply on that one, and then they will do the analysis. There is two analysis. One is loading analysis, another is thermal analysis they will do, and they will check on which the allowable they give on that one. On that depending on that one, they will consider that one whether it will be within this allowable limits or it's crossing that one. That it shows in some indication in the colors. If it's red color, then it is crossing the limit and that one. And if it is in blue or it is in green, then it's under limit, like that. It is like that there. It comes report comes in the charts and that one. It means it's in figure. There is a where red comes, it shows that this is the red and this crossing the boundary and that, like that they'll do.
Okay. About stack heat exchanger. If how to calculate their foundation load, like wind shear, wind load and seismic load. In normal heat exchanger, we put a saddle operating condition. But in stack, how to do it?
In stack, normally that one exchanger is mounted on other. So first you whatever the loads and that one you're transferring to bottom saddle, right?
Yeah, I have calculated the top exchanger load for each saddle.
Yeah.
Operating condition, empty condition, hydro test condition.
Yeah. Similarly, this wind loads and that one, the total height of the equipment you have to consider. The total means two exchangers height. You have to mention
total height of both exchangers will helpful in moment.
Yeah, in moment and wind, because wind the height, whatever the total height you mention in the wind factor and that.
How to calculate wind?
Wind actually that given in the wind means their client specification. Normally the wind speed is there and wind factor is there, and plus wind
speed is 180 km per hour.
Yeah, and wind safe factor is there.
Yeah, wind safe factor is 0.8.
Yeah, and plus they given that height of that equipment.
Okay.
So in the height of the equipment, you have to mention this both the equipment, whatever total height comes, no? You have to mention.
I have.
Yeah, you have to mention that height. So this wind speed, what your 180 you said, no, that wind speed applies on that total height of that equipment. So it will check on the bottom of your saddles, so whether it will be suitable or not.
Okay. Okay, got it. I will do it.
Okay. And this wind and that one, no, whatever the height, how to consider that one, that's also given in the civil code, and that one, that's XC7. In XC7, if you refer, it shows that how to take that factors and that one.
Okay. AC7. Yeah,
Yeah.
got it.
So it mentioned that means what height, what factor need to be considered, how it will acts on that one. It gives that one.
Okay, got it.
In this heat exchanger, also you will do floating type and that one, no?
All type.
All type. So in floating type heat exchanger, when you are putting, means you have the workshop also, no, in your place.
Yeah, I have workshop also.
So how they will push this one inside that means one the main shell is there, and another one is floating is inside. How it floats means any supports, how will provide that one?
I think you are saying that how to they push floating head.
Yeah, how to
In main shell.
yeah, initially how to place that one means from one end to other end, how you will push that one?
No, in bundle there is a option. I will provide sliding strip. And floating tube sheet is in the air all the time.
You will provide the flatting strip.
Sliding strip on the tube bundle. Then tube bundle
Sliding strip on the tube bundle.
We insert backing ring and floating blade into the tube bundle.
Okay.
And this is and we assemble bonnet to main shell, bonnet shell to main shell. Then we insert tube bundle in the main shell. With the help of the sliding strip, it will smoothly included in main shell.
Okay. So this sliding strip after installation you will remove, or it will be inside the shell only?
No, it is a permanent joint.
Okay.
Sliding.
So this sliding you connect to shell or you connect to tubes, tube baffles and
no,
that?
we sliding strip is tube sheet to last baffle.
Tube sheet to last baffle. Okay.
Yeah.
So it is only at the bottom place, no?
It is a 180 degree.
180 degree. Yeah, bottom side 180 degree.
Hmm.
So how this sliding strip, how it will be? Means it's a square one or flat one? How it is?
No, it's like a filling strip. Nothing else.
How it is? Pardon?
This is like a filling strip.
Filling strip.
Just a perpendicular.
Perpendicular.
Only.
Okay. So when you slide this one, so it will directly it goes. Means it's rubs to the bottom of the shell, right?
Yeah.
While sliding inside. So this connected to your tube sheet to end of the tubes buffets.
And backing ring is also helps with this assembly, because backing ring in two holes always.
Two?
Backing ring in two holes, two split ring.
Two holes in
when you push only bundle in the main shell, tube sheet, stationary tube sheet with bolted with the main channel plane and sandwich or anything. Then backing ring, there is a gap minimum 20 mm beyond the shell plane bonnet side. Then backing ring will start. Backing ring will start. Due to backing ring in two split ring, we assemble it first. Then we assemble floating flange. So there is a very easy practice in the production.
Okay. So production first you will assemble the backing strip and tube side, I mean floating tube side things. Then you will add this, right?
Yeah. Yes.
Okay. So your floating tube side channel and whatever will be there, that head and that one, that always it is in floating state.
Yes.
Okay. And this, if this sliding strip If some nozzles or something comes on that side, then how it will be? You will change that flow.
No, if there is any nozzle, although tie rod is not allowed to in the inlet side.
Mm-hmm.
Inlet will always free.
Mm-hmm.
We shifted sliding strip.
Okay, so you will shift that one. So these are
Yeah, we shifted.
okay. These all are taken care at before only before.
Yeah, we just put a offset of a nozzle ID, how much, and then we will track it how to where we have to establish sliding strip.
But this sliding strip normally in drawings and that one they'll not mention, no?
No, already mentioned. All drawings have mentioned in two bundle drawing.
In two bundle drawings they mention that sliding strip and that.
They mentioned, and although also in Seismic Tubesheet we also saw it hidden.
Means hidden you used to show that one.
Yeah, in Tubesheet we also saw hidden, and Dapple we saw it.
Mm-hmm. Okay. So because way some of the drawings we done and that means we seen that one where we're not used to mention this because this is in production requirement. This is not the design requirement. No? So production.
Yeah, this is the only production requirement vibration. But this can be help in the vibration control and bundle with always inline support.
Uh-huh. Okay. So this also helps to vibration also. Means in transportation.
This also helps in vibration and keep bundle in one line.
Mm-hmm.
If my bundle have 10,000 tubes,
mm-hmm.
then it will when we taking up care with cranes,
mm-hmm.
so it will react like a snack.
Yeah,
if we did not provide, it will react like a snack.
Mm-hmm.
Cross zigzag.
Yeah.
Then sliding strip is help because any ceiling strip can't support this condition. Then sliding strip will also requirement.
Okay. So this sliding that supports, but it is a simple one strip, no? This also will be sag, no? Along with two.
No, this is one pair. One pair. Offset from center, like 180 degrees, 100 mm, 100 mm. Because this will be provided in 180 degree exact. Then bundle can be rotated anywhere into 270 degree or 90 degree. If we provide like a pair, all bundle load will react in 180 degree. That sliding strip will hold all the load.
Okay. So these are the additional things we have to consider in the manufacturing.
These are the additional things, but all EPC, PMC consultant technology providers are mentioned in their guideline for tube layout. They required sliding strip, filling strip.
Okay. So normally we need to provide that one. And this tying rod and that one, it's you are saying that it's not allowed something.
What?
This tying rod of this buffels and that one.
This is like a flat, 50 wide, 8 thick, like.
Okay. It's just a strip. It is 50 by 8.
Yeah, just a strip, nothing else.
Okay. Any other this floating tube sheet we have to take care while in assembly or in manufacturing? Because you are having the manufacturing also.
We have to focus on the gap between bonnet flange and backing ring, because mostly we see after assembly, the floating assembly, bolt stud size or minimum 50 mm shall be outside for 2 threads.
Okay.
Then after we have to consider 20 mm gap. Because if we consider only 20 mm and we did not count up 15 mm thread will also outside of the assembly, then there is also in calculation we will receive 5 mm gap only. And in production 5 mm is nothing. Then for floating flange and backing ring will slash and assembly can't complete.
Okay. So we have to give them more gap.
Yeah, so then our practice, we provide like a 50 from backing ring cell side phase to cell side bolt phase to bonnet flange.
Okay. So you will keep 50 then it will be better.
Yeah, it will be better.
Okay. So these you have to mention in your drawing and that one, no? You will mention because these are so you will keep on mentioning. Means your drawing also you will check, no? So you will
No,
rather than design only how they are doing.
yeah. Well, practical knowledge is very important.
Yeah. Also,
We can imagine a thing, then we can design it.
Yeah. So better
Sir,
understand. Yeah.
How to calculate crown blank dia?
Crown blank dia.
Hmm.
So it's given in this Dennis mouse and that one, no?
No, I don't think so. There is a mention. Then I will try tomorrow and Monday if there is any mention, because crown is like a two type, with lip or without lip. Then black dia will change also, with lip or without lip.
Yeah, that only you have to add that lip additional. Normally, crown and that one, it's a 0.1 times of that, whatever the radius and that one, no? 0.9 times.
The crown radius is 0.9 of the cell ID.
Yeah, so you have to consider.
But I have to form the crown, then I will require plate sizes more than the crown.
The plate size again, this is actually the formation of the crown. The formation of the crown,
The formation of the crown is required more plate.
Yeah. Normally, it's
how much plate I have to?
Yeah, this is this calculation normally comes from the who does this crowning and that one, no? Because different pressing machines are there. The different factor they need to considers.
Yeah, maximum forming in carbon steel is 17%. Minimum is 15%.
Yeah, again, this 15 and 17% whatever you told, it's actually depends the skill of the person who is doing this crowning activity on the press machine. So if press machine, the person is very experienced in that one, the formation or deformation will be very less along with him. So he will exactly form that crown within few punches or that one. So that crown will be formed. But if the non-experienced or less experienced person, so he require more punches on that one. So accordingly, the plate length also required more, like that. So actually, it depends on the means who does the crowning activity. So you have to consider the person who is doing the crowning activity. So accordingly, you have to. But judgmentally, in just you have to add the whatever the 17% maximum you told them, that much you can add in that one additional on your plate after the what radius point and you considering in that one, and the lip additional.
It is okay. I have speak up with five big major companies in fabrication. Their engineers said there is no any specific formula to calculate black die crown, but in carbon steel we can go with higher margin.
Yeah, that's what I'm telling.
But
but you have to specific formula means actually it's on the experience-based person who is doing the crowning activity. So you have to consider that person only where you are giving this job to him. If you are giving this job to him, so you have to ask what plate I have to cut for you. So accordingly, he will tell that he suggests that give me this size of plate. So he will form that one. So when you consult with that person only, he will inform you. So this is the size he require, like that.
My concern is like if my blank die is coming 1300, but if it is a carbon steel, I can provide 1400 also. The carbon steel is not too costly.
Yeah, 1400 also you can provide that one. But again, the crowning person, if he require only 1350 and you provided 1400, so additional that 50 he used to cut in his workshop or his place. So that's why you have to consult the person who is doing the crowning activity, and whatever size he says, so you can depending on his experience, he says that I require.
Forming we outsource. So then their worker will not guide us how much we required.
No, but size you'll outsource, but you'll along with plate you'll outsource, or without plate you
No,
outsource.
no. Plate is our, but the length dia we make template, but we also in template we provide margin 20 to 30 mm. But my plate material is monal. Monal is very costly.
Yeah, yeah,
Then how last week this has happened. My crown dia, my material was monal. My crown dia was required is also 400. In a drawing there is mentioned 780.
mm-hmm.
And then monal will cut in welding, and our seniors will get very angry that monal is wasted now, and monal is too costly.
Yeah. So you mentioned in the drawing and you cutted that one, but you didn't consulted the where you are outsourcing for this.
No, outsourcing person did not contact with us directly. Planning will connect with them. That's why we can't do anything.
Yeah, you have to inform them because this is the not based on the formula or anything it comes. It's based on the person who doing the crowning activity only. They can tell the what size he require. Even if you mention that, even if you mention in
We
the
have
drawing, no, mention that the
no,
person who is doing no, he makes because he means in my experience he does that what your drawing mentioned. It's he want to make that false means it's a wrong information. So he want to make his the judgment or when you mention that diameter he used to press more or maybe press less like that he'll do. So he want his only the value to be given the blank size. Then only he will do the right one. Even if you
yeah,
he says there's something different. So whatever he says if you give the only he'll form that size like that.
yeah. We developed two formulas for with lip or without lip.
Mm-hmm. Okay.
Uh, that's why they formula are now we are thinking this is okay
No,
for
okay
with
means
lip or
again
without lip.
if you give and if the plate is more costly, so then you may waste. Better to consult the person who is doing this crowning activity, and then only if you provide that exact size, so he will because he only said this size and you given that size, so he will not waste that one, and your material also will be get saved.
Yes, yes. But ground eye is a deeply thing, and an engineers, planning engineers can't go with very deep, because every default, every error is coming from design, and design is responsible.
No, design, this is not a design problem. This is a manufacturing issue because this manufacturing, they are
Yeah,
crowning with press machine. So press machine, how much he forces to give the punches or how much presses it does on his skill in that one. So accordingly, it will be deforms. The water material deformation will starts, no? That will be depends on the press machine expertise. So it will not in designing, no, it will be manufacturing fault. So whatever the size he says, we have to give that manufacturers like that. Means as per my experience, it will be like that. We used to do.
yeah. But teams make this issue very high.
Uh,
That's why I'm telling that
yeah,
because
if you
nobody will
take
take
that
a stand for us.
responsibility on design, no, many times
Yeah,
it will
yeah,
become the wrong. That person
yeah.
always make it is wrong. Whatever you given it's wrong because he want to his authority on that one. So whatever size he says that it to be correct and like that. So that's why he
Yeah,
want to.
because every will say written is okay and written by design. Nobody will take a stand for us, and nobody will guide how to do this.
Yeah, when there is a mistake, then it comes to design only. They will say that all the mistakes from design and that one.
Yeah, always design problem, design problem.
But actually, these are not design problems. These are the manufacturing problems.
Yeah, this is not design problem. This is also beyond we provide 10 mm in neck
Yeah.
planning margin.
Still, it will be because the former, if he presses more, then it will be the.
Yeah, yeah.
It goes over beyond the formation like that. So you have to keep the some contact with those persons who presses and wherever you outsource, no, with that who is doing that workers in that one. You have to keep contact. So
Yeah, I'm planning a trip in. No, no, we can conclude.
okay, we can conclude. Okay then, see you then. Bye. Good night.
Bye.